don't think I can judge whether either of these capacitors is totally shot. Maybe wasting my time and effort changing them. You know, eventually they're going to be bad guys. Orange. Okay, so now putting in the new ones. Okay, so I guess I'll just go one at a time here. First one would be this brown one. The brown one is a 10. The 10, this is my 10 at 100. The 10 has 50 volts across it according to this. Good, that'll do it. So that'll be one in. This will be the easiest one of them all. Let's put one in like that. Okay, I'm going to cut these other wires back here because they are no use to anybody. Those are the leads coming out of the original capacitor. Get them out of the way. 10 negative. So I can cut this negative wire off. Actually, this terminal is so busy. You should melt it off, pull it away. And then there's this negative too, which has also got to go. That's the negative to the old capacitor. So let's desolder that guy there. Wire off too. This might be hard to get off. Hard to get off, it all fell off. That was not put on there very well. And it makes me wonder if that's also a replacement from the original. Okay, that terminal's ready. Bring on the capacitor, double checking. I don't have the right one, that's why I double check these things. So I can make my mistakes firmly. I make my mistakes with the knowledge that I'm absolutely correct in what I'm doing. That's the best way. Now I'm going to be putting an awful lot of things onto this negative terminal. So I'm not going to be soldering this right away. Not the negative side. Okay. The other end goes where the brown wire was. Get rid of this excess black. Get rid of the excess brown. Get rid of the excess lead. Whoops. Okay, so that guy's in. We'll solder the positive end of it. One done. Next one, just work our way back. Next one is this, let's say the orange one here. It also has this red wire, orange and red. Orange is a 30, 150, so this is 33 at 400. So this is heavy duty in comparison to what's actually in there. See the speaker comes up through here. It's going to knock this. I'm going to be replacing this capacitor eventually. So I just don't want to put the new one, you know, where it can't go. Doesn't that make sense? There's lots of space here. The wires aren't long enough, and I have more. Let's fit them all in and take a look at the situation here. So I've got to put one of these in roughly to this terminal. I'm going to put another one in going to this terminal, I believe. Then I got to put this one in. This one is the yellow wire, isn't it? Yellow is 30 at 25. That's right. So this guy actually attaches way over here. He could make it all the way. Get all the way through there. And I'll be changing all these. These are all going to get smaller. All these capacitors, or most of them anyway. So I could do it like that. This one's a little high. I don't quite like where it is. Move it up further. Put it in here. Too bad I cut the black wire off. I was a little quick on that. Could use that black wire now. And use the red one. Use this orange wire. That's it. So I need to attach two fairly long black wires on the negatives here, because the negatives are the ones that are going to be reaching for that terminal. Okay, I'm going to put all that in. Okay, time for a bit of soldering here. Okay, that's good. That's my negative lead extensions. Okay, now I want to desolder this terminal. Get some of the solder off it anyway. It's got two wires on it that are going to come off, this red one and the yellow one down there. It's a huge terminal. This guy goes on that terminal. Wow, there's wire strands sticking out all over the place here. Amazing that wasn't a short circuit. Missed. See if that pops right off when I go to solder it. Okay. Positive, negative, negative, positive. That's two in. Pull out this yellow wire now. That goes in my hookup wire collection. Find itself back in another radio. So now we are left with these two terminals here. So this capacitor's in the way a bit. Shame on me. I should have laid it out here more. Oh well. Okay, so these two guys, the negative's got to make it to this post here. Well, the positive goes there. If I put it there, I didn't need to extend it. Extend the negative. That's a good spot. That's slightly better. That's really back there now. I'd have to extend the... Oh, I don't have to extend it. Extension's there. Perfect. Okay. And then the red wire. This is sitting here. Red wire. So we'll keep the insulated part as long as possible. put a little cover on. Hey, maybe this will do. Yeah, it's not red. I see that. Okay, it's a pretty small diameter, but I'm going to give it a go. Cover my splice up with it. As long as I make a nice, neat splice. Whoops, put this on. I'll slide it back as far as possible. This to shrink the shrink sleeve prematurely. It's almost always what happens in these cases. Okay, kill the heat. Don't get to my shrink sleeve, please. It's a crazy way to cool it off, but that's what I'm doing. That's a crazy way to find out how hot it is too. As you find out it's really hot. There we go. That's nice. Okay, this goes over here like this. Whoa, way over there. And then this goes down in here. This goes here and this goes here. Good instructions. Big terminal when I get done with it. That didn't go well. That'll probably do. Now, last one. So the last one is connecting to this terminal with the orange, and also, so I was thinking of doing it like this. Good, that'll work. Teeny little bit of wire there. That should be enough. Put a little shrink sleeve over it too, but wow, there's not much clearance here. Like I can't move the shrink sleeve far enough away from the joint that I'm going to be heating up, that the shrink sleeve won't shrink again prematurely. Come on, go in there. What's the Well, we'll just try it. I mean, if it shrinks, too bad. Now, what I'm going to do is I think I'm going to solder this terminal up right away, because there's so much on it. In the Edison movie I was watching, there's a scene where Edison and his guys are starting up two generators that they built to power streetlights. Two generators, and then they decide to put them in parallel. So they get them spinning. They're steam powered, of course. They get them spinning, then they throw the switch to parallel the two generators. It's very exciting in the movie, actually. Quite convincing that that's really what it looked like when they did it. And the sparks start flying everywhere, and everything is going crazy. So in the movie, he's probably got a half dozen assistants. They're running around, smoke, flames, noise, everything going crazy. They have no idea what to do, and you can watch Edison calmly walk through the smoke and the flames and stand where he can watch things and make observations about his machines, which appear to be flying apart and burning up. And he suddenly reaches a conclusion. This is what I liked about this movie, is that the stuff that they were talking about actually was technically accurate. He says, hey, these two generators, one's pumping power into the other. One's like a motor. He goes, we have to synchronize these. Throw the switch. I was thinking, wow, is it really like that? Could a guy figure that out just in the midst of all that? Was he really that calm, cool, and collected? Watching months worth of hard work burn up right in front of him? Maybe he was. Anyway, they quickly managed to synchronize these two machines with an additional mechanical fittings on two of them, and next thing you know, street lights in New York City. Now the interesting thing about this is I worked in the city of Toronto for the power company, and doing lots of different things, and had occasion to see stuff and read about stuff and whatnot, which was kind of cool. One of the things I saw was the early Edison distribution system that's buried in the streets of downtown Toronto. Put in, I don't know, very late 1800s or very early 1900s. Steel pipes about this big around. Here, let me use the other camera. I mean, steel pipes about this big around, I guess. In it would be 3 solid conductors, and around each conductor is wrapped rope, and that rope spaces the conductors from the steel pipe and each other, the rope, and then into the pipe is a whole bunch of tar, basically tar, to fill the pipe to make sure no water gets in there with it. And then these things were made in, I think, about 20-foot lengths. He made up lengths, maybe it was more, and then jointed each of the pipes together in a very plumbing-like sort of fashion. So in the end, you had a continuous pipe, a watertight pipe, and inside it was the cables. When it came time to make a splice, they put a box in. This is what I saw, a box, and I can't even show you here on my bench, the size of a automobile differential. In fact, it looked very much like a differential. And so you have the main cable coming through, and then you want to make a Y off of it, and so you have this bizarre looking big iron box buried under the streets and been down there for, at that time, 80 years, something like that. And what had happened was some people had dug this stuff up because they're doing work in the streets, and then they find these things, and then they call the gas company and the power company, hey, come look at what we found here. And I knew what it was because I had already seen the old records of it in our office showing this very old street lighting distribution system long since abandoned. Yeah, interesting stuff. said I was going to solder that, didn't I? And I didn't do it. Okay, right now my soldering iron's still going. I get so excited. Thomas Edison. All those guys. All those guys who took the time to think things through and not accept the curiosities in life, but to work at them. Cut this wire off. Well, I'll try pulling it off when I hit that with it. Oh, now I'm going to cut it away. All these guys, these handful of people who hold the main responsibility for the world we're in now. I guess you could say if one guy didn't think it up, somebody else is going to think it up pretty soon afterwards. In fact, when you look at things like, you know, who invented the telephone and that, it's quite debatable exactly who did it, because it was being invented independently in multiple places. Let's do this one first here. There's somebody in Europe who has a pretty legitimate claim to inventing the telephone. And of course, we all know the telephone, the actual invention, was done here in Ontario. You know, the Watson, come here, I need you. Is that Edison? Have I got people mixed up? It's just a huge, huge terminal here. Another problem is my soldering iron is timed out. So the greatest thing about this soldering iron is I can't leave it on by accident. And the worst thing about it is it keeps shutting off in the middle of me using it. Good and bad, coming from the same thing. How can that be? Okay, soldering iron, let's do the job now. Everybody, there's enough solder to go around, guys. Come on, everybody jump in the pool. Hey, this guy didn't get in the pool. Okay. Got caught. There we are. This one here. Whole thing missed. Okay, let's shrink this. Shrink this a bit too. I guess we're going to be able to turn this thing on and try it out. Can't exactly plug it in unless I put a new power cord on it. Well, I put my cheater on it. There we go. Now, once you turn this radio upside down, and these two capacitors are going to drop right out. Or if I leave them like this, they're going to basically lay on the bottom of the radio. Why? What's going on here? How come this is up from here? I would think this is the bottom plane here, not here. Yikes! Is this? It can't be. Maybe there's little stands or something. Oh yeah, there is. There's little stands. Think about this for a second, Jim. That bolt's there, that bolt's there. Yeah, no problem. Okay, so what happened there was I became worried that some of my work was too high up on the radio and would be protruding. Over here. Be protruding based on this. No, not a problem. So all I got to do is just kind of attach these in a simple way. Some simple grip on here will do it. Not too much. I just don't want them rattling around in there. So I'll do that with a couple of these guys here. I don't even have to get the I don't have to do it around the body of the capacitor at all. I can even do it on the wires here. Do it anywhere practically here. That's if I can do it. That's only if I can do it. I can do it only if I can do it. Trying to hook it around so I could put it onto the... No, I don't want something going over top of this. Same ideas are coming fast and furious here. The top of this has to be... You can't have that touching something either. Just leave it. just leave it. It's not really catching anything. The movie on Edison, part of the movie is about him inventing the electric light bulb. Now again, I don't know really historically how accurate this is, but according to the movie, he's on experiment number 9,000 when he tries a carbonized thread and gets a bulb to burn for 40 hours. He certainly wasn't a guy for quitting, that's for sure. You can't quit. 9,000 experiments. Now I've heard varying stories here. I've heard that somebody else had actually invented the successful filament and he bought the patent. I heard this story, but I don't know. I don't know what the truth is. Of course, today, if he came back, that's pretty tight. Came back on the planet and he looked at the lights here in my shop, he'd say, "Hey, where's the filament?" Sorry, Edison, your time has gone by. We've done away with the filament. Now we're using now we're using a solid state device within which electrons are elevated to higher energy levels and then drop back to lower energy levels, releasing a photon of light. What do you think of that, Edison? I think his answer would be, "What are you talking about?" And then I think because of the kind of guy he was, he would probably get really curious and want to know a lot more. And then he'd probably invent something fantastic shortly afterwards. Yeah, I think the Yahoo moment, where you I said, "Yeah, I've got the solution." I don't think that happens very often. I think it's a lot more, let's try this, let's try this, let's try this, let's just keep trying this. I think Tesla was a different sort. Tesla, the claim is, Tesla was able to think his way through every problem to the solution in its final form. And I think he had a bit of a reputation for never being wrong. Hard to believe. I heard that Tesla designed the generators at Niagara Falls. The first generators installed at Niagara Falls, designed them, of course, in his head. Put the drawings together on paper. They built it. Never built something quite like that before, or at least to that scale, and it all worked. And I believe they may still be there. I doubt it. They may be. The Tesla generators. Okay. So what have we done here now? Just review, Jim, because you're not thinking so carefully. That's in. That's in. That's good. Well. Yeah. Yeah, what? Yeah, I think we can actually test this radio now. I just put the power to it and see what happens. I gotta connect up the speaker. Oh yeah, where's that go? Uh oh. Oh yeah, right up here. That's easy. I'm connected with clip leads for now. I don't want to solder it in. That would be kind of crazy. Put it on the output transformer. Now we got to do a little bit with this power wire here, which is not going to help anybody anymore. Oh, that's a crunch. That's not supposed to crunch. Schmozzle there. Okay, I'll cut this one here. Cut this one here. Ooh. So now I've got two. Where's the other one? Two wires here. Okay, so I'm going to move this other one up. The insulation is going to break right off it everywhere. This guy here. Ugh. strands wandering around, which there are not. Likewise with this guy. Oh, hey, over here. Okay, now I'm going to take my... This is the point where someone like me says, don't try this at home. But I'm using just plug with clip leads sticking out. Can actually go right on here. I'm leaving these tails of wire here because they mark the terminals. Actually, I'm going to use this one. But you see, they are sticking out all over the place here, so I got to be conscious. I have to be conscious. That's good though. I've done two big cups of coffee. Boy, am I conscious today. I'm telling you. Now, how about we take the farther away camera shot. Doing a little bit of lighting work in here last night and elsewhere in my house. A little bit better lighting in here today. Speakers connected, power's connected, wires are kind of safe. I'm going to clip away some of this because it doesn't need to be that much there. Just this one too. Okay. Now, flip it over? No. Leave it like it is? Yes. Turn the speaker like that. Bring the camera in a little closer. Hey, over here. Whoops. Tighten that down a little better. Okay, so this is tuning, obviously. This is on, off, and power. Now, is that plunger pushed? That plunger's not pushed into this arrangement, is it? It is pushed a little bit. So let me get something under here, make sure that's not pushed, because I don't think that would work out well if that switch is depressed at all. That being the battery switch. Switch is airborne now, it cannot be pushed. Off. Okay. I'm standing back. Now, first thing we want to do is find out if the switch really turns the radio off. So, now this is a kind of a low power radio, so it's not likely to draw enough power to make these lights even light up. In fact, I'm going to undo one bulb here. So all the power has to go through the lower wattage bulb to try to restrict it as much as possible. If I flip the power on, this thing comes on really bright. Something wrong here. If I flip the power on and nothing happens, that's exactly what we want, because the radio's turned off, right? Yes, turned off. So if we just tip the camera up a little bit higher, there's some voltmeters up here. Take a look at. So this one shows my line voltage just in the house all the time. It's reading 120, but it's not terribly accurate. And this one shows the voltage right at the end here. And of course this thing itself, this gizmo I have, shows the voltage too. But this is digital and you have to really think about it. This is just an analog meter. So what should happen is, with this off, when I flip the switch, this meter should rise up and read the same as that. Here we go. There it is. You also may have seen this meter go over too. So this meter is a little corny the way I have it. It's a percentage meter. So it's showing you the percentage of this voltage reaching the end of the outlet. And it's at 100%, 120 plus, 120. So that means the off switch works. Okay, thumbs up. It's good to know the off switch works. Now when I switch it on, it's going to draw some power. If it's a bad deal, then this light will come on really bright. If it's not so bad, this light might come on a little bit, and this meter will drop down and then probably rise up, but we don't know. So those are all the things to watch for. The main one is this light comes on really bright, scares me all the heck. So also, because I'm a chicken, I'm going to turn the power off here, turn the radio on, I'm going to turn it on up here. You ready? 3, 2, who needs a countdown? So this went all the way up. Those lights did not come on. That doesn't mean anything. This radio should come to life almost immediately. Okay, so far, what's the story? So far, it would look like there's no power being drawn by it. So I can turn this to watts. So it's 123 volts. 0 watts. So it's not drawing any power. So now, careful, Jim. You just picked up the clip lead wire. Careful, man. What are you doing? Oh, I know why. For crying out loud, I got the rectifier tube out here. So sometimes the troubleshooting that takes place in here is fantastic. It's just beyond belief. Okay, no rectifier tube in the radio. Here's an empty socket. Let's put it in there. Okay, now, so basically what that last thing was a rehearsal for this. This is a real McCoy now. But we're all trained. You know what? This is actually sitting on the output tube here. That's not so good. There. Okay, now this time's for real. It's connected there, it's connected there. Switch, so okay, guess I've been in here a little too long because I kind of lost my head just now. Okay, off, on, there we go. Oop, just to give you a little better view here. Everything in the picture. Okay, I'm doing it with the switch this time. I'm watching the lights. Light on, meter down, meter back up. Perfect. Volume up. Some sound, some sound. So a radio like this should come to life really quick. Okay, not any sound in the speaker at all. Did the wires come off? Am I using a bad clip leads? It's not a sound at all. Okay, so are we drawing any power? Watts. 8 watts. 8 watts. You know, that's not unreasonable. I don't know that that's correct, but it's not unreasonable. Flip the radio over, no way. I got these wires clipped here. Listen very carefully to the speaker. Yeah, I'd say there's absolutely nothing coming out of it. Okay. I'm going to flip the radio right over and power off. Flip the radio over with these wires in it. How's that going to work out? It's not going to work out very good. So I need to stand the radio up. Okay. Power's off. Turn it completely off. Absolutely off. Okay, let me look at the power connections here. Make absolutely sure we're golden. My mirror must be elsewhere. Okay, let me look again. Okay. In fact, I can tip this a little bit. It's all good. What am I forgetting about? Let's bring the speaker around to the front. Let's move this whole thing there. So we could have bad clip leads. That's happened to me before. Could I have attached these to the wrong spot? I just don't think so. Okay, clip lead check. Clip lead check. Here he is. Here he is. Could be maybe the speaker's defective. It's good. One thing I have little patience for, it's problems which just get bigger as you try to deal with them. Like, you know, your thing falls over and then it comes out of its thing and it knocks something out. That frustrates me, something terrible. What am I doing here? Checking the clip lead. Yeah, that's true of everybody though, isn't it? Clip lead's not a problem. There goes the meter again. Clip leads are not the problem. What about the speaker itself? We have to prove everything out here, one step at a time. So, a quick and dirty way of checking that is with a battery, especially one that's mostly dead. I think this qualifies. This could be just entirely dead. Any sound? Then we have to check the battery. How about this one? These are these really old batteries I have. Hey, I don't think you're that dead. Okay, better testing technique would be to use the things falling down in here, stuff falling everywhere. Let's use this guy. Give him a real test. Give it a moment. Okay, Mr. Speaker. Let's give him the load test here. Something buzzing right around here, but it just could be because it's just sitting in the open. To my ear, about 150, it's gone. 100, maybe 140. Put it in the cabinet, though. We'll probably hear a little lower. Hey, how about high? Ooh. So would you believe that's right around 15K? That's like 14. Now I can't say for sure what I'm hearing is actually the frequency dialed up here, because there could be some harmonic effects, so you think you're putting in 15 and 7 is what you're hearing. I don't know. But anyway, speaker not a problem. The speaker is not the issue. We can assume now that the speaker is proving there's no output from the output transformer. Looks like I can see this lead is soldered to the transformer, which is riveted to the chassis, but it's loose on its rivets. Okay, who's got some warmth? these are very low wattage tubes, so not a very valid test. If one heats, they all heat. It should be the way it works because they're in series. I think they're all in series with each other. Oh, that's right. Yeah. This control works backwards because I believe when it's protruding from the radio, it makes sense the way it's turning. But here, it doesn't make sense. You turn it on and turn it the wrong way. Oh, such fun. Well, I don't see why we wouldn't try this again. Now, without a doubt, this switch is not plunged. Well, we did see it draw some current, so that doesn't even make sense why I said that. Let's try it again. Okay, switch is off. Power's on through one light. Switching on. And I'm going to watch for everything to heat up here. See if it really does. Give it a minute anyway. Oops. Let me check the wattage on the 8 watts, so it's drawing power. To imagine the power is the tubes heating up. Okay, so in the dark here I can certainly see this one. How could they not be heating up? Maybe, you know what? This one, this is the 117 volt one. Guess what? None of the rest are heating up. I'm seeing a reflection of the red from this one over in this tube. But none of the other tubes are heating up. Okay. I think we know the nature of the problem here. You know, this has actually got 1, 2, 3, 4, 5, 6. This is a 6-tube radio, not a 5-tube radio. So either we got an open filament. Man, why is there so much red here? You know, there's all kinds of red lights in my shop here, and they're reflecting on the top of the round bulbs, and I'm seeing red. I'm thinking, hey, that's a heater. No, there's no heater in here. We could check for B+. How can I do that easily with it the way it is? I can't. Okay, lights on. Lights, cameras. No action. Power off, power off, power off. Okay, so if we take a glance at the schematic, we'll of course remind ourselves that the rectifier tube's right off the line. So that's why that lit up. These guys are all in series here. Any one of them is going to wreck it for the rest. Now I've tested the 3Q5, and the rest are 1, 1, and 1, and 1, and 1. I got 4 tubes to test. And that's what's going to be next. Tube testing. Thanks for watching.